39. The base of a solid is a region in the first quadrant bounded by the x-axis, the y-axis, and the line x plus 3y equals 6. Let me rewrite that. Plus 3y is equal to 6. Okay. As shown in the figure above. So we have this region bounded on the three sides. You can see it's shaded in right there. Okay. If the cross-section of the solid perpendicular to the x-axis are squares, what is the volume of this solid? Okay, let me see if I can sketch this up for us a little bit. So if I were to drop this flat a little bit, okay, drop this on side so I can try to show the squares coming off of it, we would have a shape that looks like this. I have this triangular base. That's not half bad. It's not half good, but it's not half bad. And coming off of this base will be squares. So let me see if I can draw this. So I'll have these squares that are, as you can see, perpendicular to the x-axis. The x-axis is right here, so it's this plane, not just a line, but a plane that's perpendicular to them, gives me these squares. And so I get this sort of shape. It's going to be sort of like a pyramid, but it's not like the ones we're used to seeing. And important piece here is we can see at this base I have a 2 by 2 square, but somewhere inside here, anywhere inside here, I have a side by side square. So anywhere along here, I have some side length. Let me call that S. And the area of this square, so the area in terms of that side length S, will be S squared. And the reason that this is important is if I can integrate the areas, so I have this rule from some starting to some stopping point of the areas, and we are perpendicular to x, I'll put x in there, with respect to x, that's a v. Let's try that again, with respect to x, that will equal my volume. We have that rule. If I stack up a bunch of flat areas, I get a volume, relatively flat. Okay, so here's the trick to it now. I need to somehow measure S in terms of x. And what I have this equation. So I have x plus 3y is equal to 6. And I want to figure out how tall this is. This S is going to be equal to the y value right here. But that changes based on x. So let me solve this for y. I'm going to start by subtracting x, and I'll get 3y equals negative x plus 6. And then the second thing, I divide everything by 3, so I get y equals negative 1/3 x plus 2. So the big idea here now is that the side length of any one of these cross-section squares is going to be negative 1/3 x plus 2. My area is S squared, so my area with respect to S is S squared. My area with respect to x now, since I know what S equals, my area of the cross sections with respect to x is going to be negative 1/3 x plus 2 squared. And I may as well just work that out. That's going to be positive 1/9 x squared, and then I have 2 times both of those, minus 4/3 x plus 4. That's not really necessary. I could have put this into the formula, and I'm actually going to use the calculator to evaluate, but it looks cleaner. Okay, and I'm going to be evaluating squares that are perpendicular to the x-axis all the way from where x equals 0 to where x equals 6. Okay, these are my limits. This is going to be 0 is less than or equal to x is less than or equal to 6. So that's going to tell me that this A is going to be 0, this B is going to be 6. So my volume formula, finally, my volume formula I'm going to use, V equals the integral from 0 to 6 of 1/9 x squared minus 4/3 x plus 4 dx. Okay, so I'm integrating from the start to the stop my area of the cross sections with respect to x, and I don't feel like doing this all by hand. You know, I could bring the 3 down, get 1/27 x cubed, blah, 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 blah. Put in the 6, put in the 0, do some subtraction, but I have decimals. Let's just use the calculator. So, turn this on and integrate. So I go to Math 9, if you don't know what's down there. I'll press 9s in later videos, but scroll down, scroll down, scroll down. Hey, fn int. I put in my function that I'm integrating, which is going to be 1 divided by 9 multiplied by x squared minus 4 divided by 3 times x plus 4. And I'm evaluating that dx in terms of x from 0 to 6. And now, by calculator magic, it tells me that my answer is 8. Okay, and I could have done it by hand. I get the same answer in the end. Bingo, bango, answer. All right, 8, B.